Apache Spark, a journey through lightning-fast distributed computing. In the early days of big data, engineers relied heavily on Hadoop MapReduce. It was reliable, but painfully slow for iterative algorithms and interactive data analysis. Jobs had to write intermediate data to disk after every step, a massive bottleneck. That's when Apache Spark emerged from the MPlab at UC Berkeley, like a phoenix rising from the ashes of disk I/O. Chapter 1. The core of the Spark engine. At its heart, Spark is a distributed computing engine designed for fast in-memory data processing. Unlike Hadoop MapReduce, Spark keeps intermediate datasets in memory whenever possible, reducing disk I/O dramatically. You write programs in Scala, Python, Java, R, or SQL. These high-level APIs are compiled into a DAG, directed acyclic graph, of stages and tasks. Spark's DAG scheduler analyzes these graphs and organizes computation into narrow, for example, map, filter, and wide, for example, group, by, join, transformations. Data is split into partitions, and each partition is distributed across a cluster of worker nodes. The driver program coordinates the job, sending tasks to executors, which perform the actual computations. Chapter 2. Resilient Distributed Datasets, RDDs. RDDs were Spark's original data abstraction. Immutable, fault-tolerant collections of objects that can be operated on in parallel. Each RDD tracks its lineage graph, the sequence of operations that created it. If a partition is lost, Spark can recompute it from the lineage, not from a checkpoint. Operations on RDDs are either transformations, lazy, map, filter, flat map. Actions, eager, collect, count, save as text file. But while RDDs gave fine-grained control, they were low-level. Enter. Chapter 3. Spark SQL and Data Frames. Spark evolved. The Catalyst Optimizer and Tungsten engine powered the next generation, data frames and datasets. Data frames are distributed tables with schema, akin to pandas or SQL tables. Datasets, in Scala/Java, add type safety and custom object encoding. Spark SQL lets you query these structures using SQL syntax, which is internally converted to optimized physical plans. Joins, aggregations, and filters are now blazingly fast, benefiting from whole stage code generation and vectorized execution. Chapter 4. Spark Streaming. In a real-time world, batch is not enough. Spark Streaming originally used microbatches, breaking incoming data, Kafka, Flume, sockets, into small chunks for processing using the same RDD API. This made it easy to combine streaming and batch jobs. Later, structured streaming brought a higher-level abstraction, a streaming data frame that runs continuous queries over unbounded data. Internally, it uses stateful streaming operators and checkpointing for fault tolerance. Chapter 5. Machine Learning with MLib. Spark isn't just a data processor, it's also an ML platform. MLib is Spark's scalable machine learning library, supporting 1. Feature extraction. For example, TF-IDF, Word2Vec. 2. Classification. For example, logistic regression, random forests. 3. Regression, clustering, recommendation. For example, ALS4, pipelines for building and tuning models. It operates on data frames and integrates with cross-validation, hyperparameter tuning, and model persistence. Chapter 6. Graph Processing with Graphics. For graph lovers, Graphics provides a distributed graph processing API on top of RDDs. You can express computations like PageRank, connected components, and triangle counting. But Graphics remains relatively low-level and hasn't evolved as fast as the data frame-based ecosystem. Chapter 7. Spark on Kubernetes and the Cloud. Modern Spark runs everywhere: Yarn, Mesos, Standalone, or Kubernetes. Spark 3.x added native Kubernetes support, enabling dynamic allocation of pods and better containerization. With Delta Lake, Iceberg, and Huddy, Spark now supports ACID transactions, schema evolution, and time travel, making it ready for data lakehouses. Epilogue, the engine of big data. From ETL pipelines and data lakes to machine learning and real-time dashboards, Apache Spark remains the Swiss Army knife of big data. It fuses the power of distributed computing with expressive APIs and performance optimizations, and it continues to evolve.